Okay, so part C, we have f of x equal to 1 minus the absolute value of cos 2x. Okay, so to sketch this function here, we'll do the same. We'll start by finding the amplitude. So the amplitude of this function here, that would be the absolute value of the coefficient of cos 2x. That's the absolute value of 1, which will be 1. So this function, it was supposed to be between 1, 0, minus 1. Now, because it has been shifted vertically at 1, so plus 1, plus 1, plus 1. So this point will be at 2, 1, 0. Okay. Then the period of this function is equal to 2 pi divided by b, and in this case the coefficient of x, which is b here, is 2. So I have 2 pi divided by 2, which is equal to pi. Okay, then the vertical shift in this case, y equal to 1. Okay, then sketching this function, because of the modulus here, we cannot get a value which will be bigger than 1. Okay, so the sketch of this function here, so it is starting from it is on an interval 0 to pi, because there is no phase shift, so it will be 0 to pi, meaning that when we sketch it, so we have y, we have x here, then the function, the lowest point here on the y-axis is 0, then the middle point, that would be 1, meaning that the x-axis has shifted at 1, then up to 2 here, then so it is starting from 0 up to pi, and it's a cosine function up to pi here, and it's a cosine function. Then because it's a cosine function, that means we need to identify the first quarter and the last quarter. So let's first find the half of this interval. So the half of this interval, it's pi over 2. That would be the half of this interval. Pi over 2. Then to find the first quarter, that would be pi over 2 plus 0, which will be pi over 2 multiplied by half. This will give us pi over 4. Then here we have pi plus pi over 2, and this will give us pi plus pi over 2. It will give us so pi over 2. Pi is just the same as 2 pi over, over 2. Okay, so this gives us 3 pi over 2, this multiplied by half, so this will be 3 pi over 4. Okay, then this point now, so it will be within this interval and this one. So this point shifted here, this one, it is here, this one, it is now here, this one, it is here. Now, because we have the absolute value, so this graph here, there is no value of y that will be bigger than 1. So the function, because of the negative coefficient of the trig ratio here, it has to first, it is starting from the negative side. So it is starting from here. So it is supposed to move like this. Okay, and passes through this point. What's the last quarter here? Okay, so this is the first quarter, and actually it has no phase shift, so it is starting from here. it has no phase shift. It's starting from here and passes through this first quarter and the last quarter here. So it was supposed to move like this. Now, because of we can't get values that are bigger than 1, that means it will be all this point that above 1 will be reflected downward here. So it will be here. So the function will be, so that will be the graph of this function. Okay. Okay, so that will be the graph of this function. Okay. Okay, so let us look at this one. Okay. Okay, so the amplitude of this is the modulus of 2, which is 2. The phase shift, the vertical shift, in this case y is equal to -1. So the graph, it was supposed to be on an on the y-axis, so it was supposed to be on an interval 2, the x-axis, which is at 0, and -2, but now it has been shifted at -1. So -1, -1, -1, so it will be on an interval on the y-axis. That will be +1, -1 here, and this will be -3. That's on the y-axis. Okay. Then the phase shift. Okay, so it has got both the phase shift and the vertical shift. So to find the phase shift, so we're actually getting this angle here. If you want, you can start by distributing pi here throughout, then you equate that to 0, or you can just simply get that and equate it to 0, which will be the same. So the first shift here, we have x minus 1 over 4. We equate that to 0, so it has been shifted to 1 over 4 on the x-axis. Then the period of this function here, the period is equal to 2 pi over b, and the b here, the coefficient of x, we can see that it's pi. So we have 2 pi divided by pi, which is equal to 2. Okay. So initially this function, it was supposed to be from 0. It was supposed to start from 0 and ends on at 2 pi. Now we can add this phase shift to identify the interval. Okay, so 0 plus 1 over 4, so sorry, that's supposed to be 1 over 4. So 0 plus 1 over 4, that would be 1 over 4. Then 2 plus 1 over 4, we can look at this as 8 over 4 plus 1 over 4. So that would be like 9 over 4. So that would be 9 over 4. So it is on an interval 1 over 4 and 9 over 4. Then we can divide this interval. Okay, so the half of this interval here, so it is starting from 1 over 4 up to 9 over 4, and because it's a sine function, so we are interested to know what's the middle point of this interval, the middle value. So it will be at somewhere here. So how do we get that? So we can add 9 over 4 plus 1 over 4. So 9 over 4 plus 1 over 4, that's 10 over 4, multiplied by half, that will be 5 over 4. So this will be 5 over 4. Then this side here, it is on the range, the lowest value, it is at 1 here. So it is at 1, so this will be the middle value here on the y-axis. That will be the midpoint. Then we have also the minimum, it is at -3. Then 1 here, which is the maximum. So it is within -3 and 1. So we can see that this point shifted here, this one has shifted here, this one is now here. Then now the graph here, we can check the coefficient of sine, which is positive. So it will start from this point. Where is it starting from? Yeah, it will start from this point here, passes through that. It will start from the x-axis, so it will start from here, move like this, passes through this point, and goes back to that axis. So that would be the graph of this function here. Okay,